Okay, this is AP Calculus Lecture 4.1b, and you should have a blank or a printout. I put it in the file section in Microsoft Teams that looks like this. But before I work these two example problems, you can do it on the back if you want or your own paper. I'm going to work example number 52 from the book. And it says to solve the differential equation. It gives us the second derivative is x squared, and it tells us f prime of 0 is 6, and then f of 0 is 3. And when it says solve the differential equation, what that means is what is f of x? What is the original equation? Y equals whatever, or f of x equals whatever. So we're starting with the second derivative of x. We need to get to the first derivative, and then we can get to f of x. Okay, so if f double prime of x is equal to x squared, then f prime of x, if we go up one level, we would integrate x squared. Okay, so that's going to be 1/3 x cubed plus c. Okay, so it says that f prime of 0 is equal to 6. So now we can plug in, we know f prime of 0. So that means for this function, when x is 0, y is 6. So I would have 6 is equal to 1/3 x cubed plus c, right? And x is 0. So we plug 6 is y, 0 is x. So that means that c is equal to 6. Okay, so now we have an equation for f prime of x. It's 1/3 x cubed plus 6. How could you check that? Take the derivative and you would have x squared, and you get right back to the original. All right, in order to get f of x, which is our question, we would integrate 1/3 x cubed plus 6. That would get us up another level to the original equation. All right, well, I always do it by adding to the exponent. So we know it's going to be x to the fourth. What fraction do I need out front that when I bring the 4 down and multiply, I get 1/3? It'll be 1/12. You'll get better with your fractions for this. Now, the x is not on the bottom there. It's right here, 1/12 times x to the 4th power. So let me improve the look of that. 1/12 x to the 4th plus 6x. Right? You can check, take the derivative of that, and you'll get 1/3 x cubed plus 6. And then don't forget the plus c. And now we're about to finish it up. We know that f of 0 is equal to 3. So I have 3 is equal to 1/12 times 0 to the 4th plus 6 times 0 plus c. So 3 is equal to c. Thank goodness they made x 0 both times. Made for a lot easier work. And our final answer is f of x is equal to 1/12 x to the 4th plus 6x plus 3. All right, solving differential equations. That's a big deal on the AP Calculus test. We'll do a lot more of that in future chapters as well. All right, pause the video if you need to, and we'll go to the printed out notes. All right, if you'll get out these notes. So this is just like something we did in chapter 2, except instead of taking derivatives, we're going to take antiderivatives. So remember, the position function is s of t. Velocity function v of t is equal to s prime of t. And then the acceleration function is v prime of t, all right, which is s double prime of t. So in these problems, you're going to be given the acceleration, and then you have to take the antiderivative to get to the velocity, and then take the antiderivative again and get to position. So it's really the same type of problem. We're just kind of going backwards instead of forwards like we did before. Okay, so get this back in, and then a bicycle traveling at 30 feet per second hits the brakes, decelerates. That just means the acceleration is negative. To a stop at a rate of negative 20 feet per second squared. What length does it take the bicycle to stop? Okay, so we want to know the position, right? How long did it take that bicycle to stop? So if we can figure out the time it took, we can plug it into position. We start out with A of t is equal to negative 20. So v of t, we would integrate negative 20. So that, if you integrate negative 20, that's negative 10 t squared plus c. All right, c is your initial velocity. When we're in position, it'll be the initial position. So looking at the problem, do we have an initial velocity? We do. It's 30 feet per second. So our velocity equation, v of t, is equal to minus 10 t squared plus 30. All right. Now we can use that to get the position function. We just integrate v of t. With respect to t. All right. Now we know it's going to be t cubed, right? So, oh, I'm sorry, I did this wrong. I apologize. That's going to be negative 20t. Got ahead of myself there. Negative 20t. All right, take the derivative of that and you'll get to negative 20. So sorry about all the erasing you're having to do right now. Hopefully, maybe some of you caught that. That's awesome if you did. But I don't want to make a new video. Okay, so we have negative 20t plus 30. And then we're going to integrate negative 20t plus 30. That's going to be negative 10 t squared plus 30t plus c. Now this c is your initial position. All right, and it doesn't tell us anything about an initial position, so let's just assume that is 0. Sometimes, like if you're up at the top of a cliff and you're dropping a rock or something, it says you're 500 feet high or something like that, then your initial position would be 500. But this case, I mean, you can let the initial position be the beginning of when the bike starts to slow down. So S of t is equal to minus 10 t squared plus 30t. Okay, so what length does it take the bicycle to stop? Well, we don't know the time, but we do know that the velocity is equal to 0 when the bike stops, right? So how about we could get time by setting the velocity equation equal to 0. Negative 20t plus 30 equals 0. So if you solve for t, t is going to be 1.5 seconds. All right, so how could I get the position of the bike after 1.5 seconds? Let's just find S of 1.5. It's going to be minus 10 times 1.5 squared plus 30 times 1.5. And that is 22.5 feet. Okay, sorry about that mistake. I'll probably put something in the comments so that you'll know that a mistake is coming and you won't freak out. Okay, and then the second one, a ball is shot straight upward at 96 feet per second. Acceleration's negative 32. How long is the ball in the air? How high did the ball go? What's the velocity the instant before it hits the ground? Okay, same thing. We're starting with acceleration instead of position. So let's get our three equations. V of t, we're going to integrate negative 32. That's going to be negative 32t plus c. That's our initial velocity. It says our initial velocity is 96. So it's negative 32t plus 96. And s of t, we are going to integrate, find the antiderivative. Same thing, negative 32t plus 96 dt. That's negative 16t squared plus 96t. Our initial position is we're on the ground. So let's say that that is 0. So s of t, some of your homework problems, that might not be the case. It'll tell you if it's at a certain height. All right, now we can answer the three questions. Number 1, how long is the ball in the air? Well, we know that velocity is equal to 0 at maximum height, because it's going straight up in the air and then coming back down, right? So remember from physics, velocity equals 0 at that point. So if we can figure out the time it takes to get to the halfway point, we can just double it. All right, so we know that at that halfway point, velocity is equal to 0. So 0 is equal to negative 32t plus 96. 32t is equal to 96, so t is equal to 3 seconds. And then times 2, because it's 3 seconds to get to the top. The whole flight is 6 seconds. All right, number 2, how high did the ball go? Well, what is the position at max height? And we know it took 3 seconds to get there, so let's find s of 3. Minus 16 times 3 squared plus 96 times 3. All right, plug that into the old calculator and you will get 144 feet. I'm having to work around my music stand here, so that's when my writing gets really messy. All right, and then finally, number 3 says, what's the velocity the instant before it hits the ground? So we know the instant before it hits the ground is 6 seconds. So velocity at 6 seconds. We're just going to plug 6 into the velocity function right up here. Minus 32 times 6 plus 96. That's negative 96 feet per second. Does it make sense that it's negative? Yeah, because it's going down. All right, going down, so that makes sense. That is today's lecture. Now hold on, don't go anywhere. I'm going to give you some hints for the homework. All right, pause if you need to. Look, all right. So the homework is page 249. And it is 51, 54. Now 51 and 54, you'll use example 52 to work that. 57, 59, 61, 62, 63, 65, and 73. All right, let me give you the answers, if I can find them real quick, to the even problems. All right, number 54. There it is. All right, the answer to 54 is f of x is equal to minus sine x plus 2x plus 6. And then the answer to 62 is 18.07 seconds. All right, I'm going to give you a hint. One of these is pretty tough. Let's see if some of you guys can get it. So the hint for number 59, you need to use a substitution. All right, that's your hint. It's a tough one. Hint for 73, I don't think number 73 is nearly as hard, but I'll give you a hint anyway. Get S of t for the car and S of t for the truck and set equal. It's probably too much of a hint, but I'll give it anyway. Hey, we're in a pandemic. All right, I'll talk to you next video.